So what is the method of Frobenius? Frobenius method actually we use when the power series doesn't work at a singular point, then we use Frobenius method. So that's why the method of Frobenius, named after a mathematician Ferdinand Georg Frobenius, is a way to find an infinite series solution for a second order ordinary differential equation, not partial, of the form a2x y double prime plus a1 of x y prime plus a naught of x y is equal to 0. And this is the second order ordinary differential equation, and a2 of x is the coefficient, a1 of x also coefficient, a naught of x is also coefficient of y is equal to 0, which will not be solvable with regular power series method. So this equation can't be solved by regular power series method. So this is a2 of x point is a singular point. That's why we use that's why we use the method of Frobenius. And the method of Frobenius gives two independent solutions. Note that independent solutions provide that the initial equation's roots are not separated by an integer including 0. If it is set to 0, then with this differential equation all the other coefficients will be 0, and we obtain the solution 1 by z. Okay, if x is equal to x naught is a regular singular point of the a2 xy double prime plus a1 of xy prime plus a naught of xy is equal to 0, second order linear differential equation. So this is a second order linear differential equation. Then there exists only one linearly independent solution of the form y is equal to x minus x naught the power r summation Cn, the compact form of this equation. Okay, the compact form of this equation, Cn is a constant x minus x naught at any point. The x is a radius of convergence, and x naught the point is interval point. From the interval points, power n is equal to summation, the also compact form of series n is equal to 0 to infinity Cn x minus x naught power n plus r, where r is the constant. So note that r is any constant determined will series solution converges at a 0 less than x minus x naught less than r. So here is a point that 0 not involved, also r not involved, open interval. Okay, this is the open interval, means x or x not involved and radius 0 not involved. Okay, understand? Got it? And now we move indicial equation, also called recurrence equation, r3r minus 2. Note that this equation comes from the solution of Frobenius method. We solve the question, then we get r3r minus 2. This equation is equal to obtaining during application of the Frobenius. Some application where r1 is equal to 2 by 3 its root. Okay, and r2 is equal to 0, where r1 and r2 are indicial roots and exponents of the singularity at x is equal to 0. Okay, then substituting y is equal to summation n is equal to 0 to infinity Cn x plus x the power n plus r into the given differential equation, and multiplication the indicial equation is a quadratic equation. Note that indicial equation also called quadratic equation, in that result from equating the total coefficients, then we total coefficients equating means we used equating them of the lowest power of x to 0. Then remark, if x is equal to x naught is an irregular singular point of the equation, then we could not find any solution of the equation y double prime plus p of x y prime plus q of x y is equal to 0. Then the indicial roots r is the solution of differential equation y double prime plus p of x y prime plus q of x y is equal to 0. Note